There are 9 important steps involved in new product development for electronic industry. In fact, there are 9 important steps which are very vital in every electronic system design and manufacturing process. All the electronic gadgets, appliances and products that you are using, they are following the same category of development cycle. In this video, I am going to discuss about the 9 important steps for designing, developing and manufacturing any electronic product in ESDM industry. Hi everyone, I am Vaibhav Sugandhi, passionate PCB designer and technology startup founder. Welcome back to our course on PCB designing for absolute beginners 2022. I believe you have watched our previous video. If not, click on this I button and watch that video before watching this one. Alright. I think you can see my screen in front of you right now where I am having a product development cycle mind map. Quickly, I'll go through different steps involved in this product development cycle and I'm going to explain each step by step. First one is all about ideation and framework. So this is one important step and this is where the product design starts. Thereafter, we have a block level analysis, which is again a second important steps in this entire product development activity. Thereafter comes a schematic design and validation of that particular schematic design. Thereafter, we have a PCB designing and validation of that PCB designing according to the industrial standards. Then we have a bill of material, which is one more important thing with respect to manufacturing cost and all those things. There we have a proto production, which is a prototyping activity for the product that we are designing in ESDM industry. Then we have a firmware development activity, which is a parallel line to the entire development cycle that I have shown so far. But yes, this is one more important thing involved in product development cycle. And last but one is all about POC validation, which is a proof of concept validation. You are going to verify your process or maybe a concept with a real-time customers. Then comes to the last but not the least, which is all about final production. So these are the 9 important steps involved in new product development for ESDM industry. Let me dive deep into each step and explain you what are the importance and significance of these particular steps involved in product development cycle and activity. So first of all, we have ideation and framework. As name only indicates, it is very important steps when it comes to new product development. We have to sit together with the customers and our engineers, or maybe my internal team and the customers, to identify what exactly customers are looking for. In fact, in this process, first thing we need to know about is all about like how the product should work like, or maybe the product requirement. What are the features they are expecting? What are the functionalities they are expecting? Or the customers, if we are targeting to, then what are the kind of features they are looking for in the entire product. Those things are listed down in this particular step. Second important thing that we do in our ideation and framework stage is all about industry standards. What are the industry standards right now running in market and how we can cope up to those standards? How we can make sure that our product is eligible for global market beyond the territory of where we are living and where we can sell by default. Okay, and thereafter the third important step is all about end result and goals. It is nothing but setting objectives or the deliverables for this particular product. Whenever we are designing a new product, we must understand what exactly the deliverables in the beginning, because at the end when we reach to the product, it should be what exactly the customers are expecting. If customer is expecting something else and if we are doing something else sitting inside the laboratory, it doesn't make any sense. That's why we make sure that we define our deliverables or we define our scope of the work in the beginning of this entire product development cycle. And this process is so far called is ideation and framework. Then after we come to the next step, which is the second important step, that is all about block level analysis. Block level analysis is very important as per my knowledge. Why? Because when we are developing a big system, we have to start developing it in the smaller cases. If we try to develop it in the first attempt itself, then very rarely we find a success in that process activity. So that's why we must start with a very small steps. So in this, again, we have two types. One is black box analysis, another one is white box analysis. Black box analysis is more of identifying the functionalities and putting them into a block diagrams. Like, just for example, if we are adding any sensor, then we are writing that particular sensor name, and then we are adding if any controller or a processor or a development board, then we are writing that particular block directly without knowing any part number or without knowing any detailed information about that particular block. We are going to add that block in the system so that we can understand what are the features we are going to get by adding these blocks. That is nothing but a black box analysis. When we go for a white box analysis, it is more of identifying the part number and studying the different category of sensors or actuators or controllers available in that particular category before selecting them. There is a concept called morphological chart and screening scoring methodology in product development activity, which comes under this white box analysis. So we are going to step forward and identify different sensors available to achieve one objective that is stated by our customers in black box analysis. So we are going to write down those different sensors, and then we are going to study different architecture of those sensors, and of course we are going to refer a data sheet for those particular sensors and select one which is suitable for our customer, or maybe the product that we are developing by ourselves. So that particular activity, and after doing that activity, whatever the block diagram we will be having, which is included with a part number, a specific part number of a specific sensor, actuator or a controller or the component that we are using, that particular block diagram is so called white box analysis. After this activity, we have something very important, that is all about schematic design and validation of that particular schematic. So after having a white box analysis in our hand, which we are having a part number of each component using, we head towards deriving the circuit diagram from the data sheet. So once we find that circuit diagram of that particular component or maybe the module or IC that we are using, then we are going to integrate those individual circuit diagrams into one particular circuit that is called a circuit diagram of our entire system. So once we have this entire system circuit diagram, we have to identify is there any errors in that particular circuit. How we can do that? Of course, we can convert that circuit diagram into a schematic by using the EDA tool, which is also called as electronic automation tool or electronic design automation tool, which is EDA tool. And in our company, we are using a easy EDA tool as for example right now. So in that particular software, we are going to convert our circuit diagram into a schematic design. Once we are done with the schematic design, there is an option called electrical rule check, which is ERC process. In that process, we will be identifying if there is any misconnection or if there is any duplication of labels or if there is any wrong connections that we have done in the circuit. If it was done purposefully, then we can ignore that particular error or warning. If it is unintended, then probably we are going to fix it in the process of designing schematic itself. Thereafter, we are going to design our circuit and validate our circuit. Of course, we are taking the help of senior engineers or maybe mentors or maybe the one who knows that kind of a circuits or maybe someone who has studied that circuit before designing that particular circuit. We are going to take a verification and validate our circuit with those particular engineers. And then we are going to go ahead with the certification requirements. Say for example, if I am selling any product in European continent or European continent, in that case I have to have a CE certificate in our product. Without having a CE certificate, it is not accepted to sell any product in European continent. On that time, we have to make sure that our schematic design itself should be eligible for CE certification. And like this, we will be having a lot of certification and a lot of other ways to validate our product to make it more flexible and feasible in market. So those kind of a certification activity should be taken care in this particular stage. After the schematic design and validation of that particular schematic with industrial standard, next step is all about PCB designing. One of my favorite but the most important part, which is invisible to most of the product outside, but yes, it is very important part of the entire story. So PCB designing and validation is being the most important part of entire product development cycle when it comes to electrical engineering or maybe electronic engineering as a main concern. In this process, what we are going to do is we are converting our schematic design designed in our EDA tool into one more file which is all about PCB layout. In this particular layout activity, where we are going to connect a real copper from one point of component to another point of component by using a special tools in our keyboard. So by doing this activity, we are really creating a PCBs with respect to EDA tool or with respect to the circuit that we have designed in our schematic activity. In this process, again, we have a lot of procedure to validate it by default and also with experts. First one is all about DRC process. DRC is all about design rule check. When we are doing a design rule check, it is going to indicate us if there is any mistake with respect to overlapping of any copper or overlapping of any wires which are unintended or which are not abide by the rules of PCB designing industry. Then we are going to validate our product or validate our design activity by using a IPC standard. Of course, we have to follow IPC standards while designing a PCB. IPC stands for International Printed Circuit, which is internationally or globally defined standards for every product design engineers in electronic industry. So it helps us to understand a circuit sitting anywhere in the world or sending this particular file to anywhere in the world. They can be able to understand it or they can be able to try to identify what are the things inside this particular circuit. And this standard defines what kind of rules and regulations we need to use while designing a PCB. DFM is all about design file manufacturability. This is all about how we are going to make this particular PCB into manufacturing level or maybe a production level. So when we are thinking about those lines, when we are making it a mass production level thinking, this is going to give us a lot of information which are going to reduce our cost structure in the iteration. So when we think about a DFM activity, when we think about a design file manufacturability, we identify whether this particular PCB that we are designing is capable enough to manufacture in our country right now with the technology that we are having. If not, then what are the alternatives that we can go ahead with? All these activities are taken care in the process of PCB designing and industrial validation. After designing a PCB, we will be having one more important thing. That is all about bill of materials. Bill of material is one important file which is in an Excel format, which gives us clear idea how much cost we need to bear to manufacture this product. It is not just about a PCB, it is not just about a component, but entire product as a whole. So when we generate a bill of material with a schematic design we have developed in EDA tool, it is going to give us a different information which are essential for developing this particular PCB, and even after manufacturing, if we want to assemble component on this particular PCB, we need bill of material. Bill of material is going to be one important stage where you are going to get to know what exactly the price point of view for your entire product development. Say for example, if you are using a 7805 regulator in your circuit, then what would be the ordering part number of that particular IC is defined in bill of material. We all know that 7805 is a general number, but LM78M05 is kind of a one part number which we need to order when we are ordering these kind of a component to our vendors. So those vital information is generated in bill of material, captured in bill of material and generated by a library designer in EDA tool. Thereafter, we will get to know about manufacturer and manufacturer part number in this bill of material. These two informations are very important when we are ordering product in large quantity. Say for example, right now we are doing a prototype, so 7805 is quite easily available and we procure them and we install them and we try our product. After that, if you are going for a mass production, say 1000 quantities per month like kind of a production, on that time we need to know which manufacturers we need to select for this particular component and what are the part number for that particular manufacturer, because the same component with a different manufacturer, a part number would change, and that kind of a part number is called a manufacturing part number. So if we are very clear about manufacturing part number, it is quite easy to procure the component in a longer run. So these informations are provided in bill of material. This is the importance of bill of material in any new product development for ESDM industry. Now we are at the 6th step of new product development for ESDM industry. Here we are going to talk about the proto production. Proto production is all about prototyping. Say for example, if I came up with a new idea to develop a new product in electronic industry, I will not go for thousands of quantity in the first iteration. Of course, because it is a validation. My idea is great with me, but what about my customers? Or maybe my customers are not sure about their product in the longer run. So how do they verify their product? By doing a prototype. Prototype is nothing but a very small amount of iterations taken care to manufacture a real, or that can be given to a customers so that they can verify whether the features are suitable for their requirement. For example, if we are going for a smart product which is related to IoT device, we are going to manufacture 5 units of them. With these 5 units, we are going to verify whether they are suitable for the customer segment or not. So this is a stage where we are going to identify a very minimal possible numbers of manufacturing our product and validating the features with real-time examples or maybe real-time deployment. In this process, we are going to handle with respect to PCB fabrication, the one which we have designed previously, the schematic and a PCB layout we are designed in Easy EDA tool or maybe any EDA tool. We are going to manufacture it in the PCB fabrication house. Thereafter, we are going to procure the component which are listed in bill of material, and then we are going to assemble those particular component on this bare PCB, which is so called PCB assembly unit. Thereafter, we will be having a board bring up activity and validating our product as a whole component. In this particular activity, where we are going to write a small amount of codes and we identify is there any problems with respect to hardware design, and of course we are going to identify is there any problem with respect to customer experience. So all these activities are taken care in proto validation or maybe proto production. Here we are going to manufacture very minimal amount of possible products so that we can validate our idea with a less cost that we can invest on this particular idea. After this step, we will be having a 7th important step, which is completely different from what we discussed so far, but very important in product development activity. That is all about firmware development activity. This firmware development is all related to the product that we are developing. If you are developing an embedded product or IoT device in ESDM industry, then firmware is all about embedded coding or embedded software development. Here, there are 3 important steps. First one, we are going to write a testing code. Testing codes are nothing but the individual codes which will test whether that specific component in the entire system is working or not. Say for example, in one entire system we will be having 4 different components. We are going to test one component at a time in this testing code. If we are developing one testing code which will test only this one component, then it becomes a testing code. Thereafter comes the second important thing, that is the module codes. Module code is all about identifying the features which are combined together. Say for example, I have one feature which requires 2 modules to work together or maybe 2 components to work together. On that time, I'm going to combine these 2 components into one particular code, or one code will be dedicated for identifying the specific feature and executing that feature. That kind of codes are called module integrated codes or module codes. Thereafter, we have an integration code. Integration code is all about combining all the different sets of module codes that we have created. In fact, in a simple example, if I want to explain you, let us say that we have a customer who is having a 10 different feature in one product. Each feature they are expecting is nothing but a module code. In that feature, how many sensors and actuators will be used, based on that there will be a testing code. But let us say about there are 10 different features they are expecting in this particular product, then each feature will be covered in module code. After this module code, whatever we are integration code, whatever the code that we are developing, that is combination of all these module code, is nothing but an integration code, where we are combining a module 1, module 2, module 3, module 4 and so on and so forth. All these modules are combined in a single code and we make it a final deliverable code. That code is called integration code. This is how firmware development activity will be taken care in our ESDM industry. Of course, this is going parallelly when we are designing our hardware. If we have a firmware developer engineer in our company and we have a hardware design engineer in our company, both together work and they will identify what their role and responsibility, and based on that they are going to develop the code parallelly along with the hardware when it is being developed. So thereafter we have a next important step, that is all about proof of concept. This proof of concept validation is again an important step. Of course, these all 9 steps are very important. That's why we call them as very important steps in ESDM industry while designing a new product. But right now, the 8th step that we are talking, POC validation, which is proof of concept validation, involve two important things. One is all about integration with a system. So whenever we are developing a code that integrates with a real-time system or real-time product that is already running in a machine or maybe in a big industry, then we are going to integrate our product with a real-time system. That is one way of validating whether our concept is working or not. If the concept is working, then it is called proof of concept. It is a proof that this concept works. If it is not working, then again we need to iterate all the previous process once again to achieve the desired result. Second important step is real-time testing. After doing the proof of concept activity with respect to deployment with the machineries or maybe the integration with a real system, there we have one more important step, that is real-time implementation. We are going to put that particular machine or the product into a real-time activity so that we can identify how it behaves with the real-time situations. Say for example, different weather conditions, or maybe a different way of using a user experience, or maybe a different method of using that particular product. No matter what kind of a condition it is, it should work in all the ways that it is expected to work in that particular way. Of course, there is no such possibility that if you dip that particular product into water without having a waterproof casing, then it doesn't work. But in must and should case, when it is kept in a little humid air or maybe a little kind of a wet surface or something, it should function at least for a certain period of time until it sends some data to the cloud if it is an IoT device. So those kind of expectations are validated with the POC validation. Next and very important but the last step of this entire product development activity is all about final production files. So this is the deliverable to our customers if we are working for a customer, or these are the intellectual property of any product if we are developing our own product. So these files, whichever we are generating after this stage, are going to play a vital role in business activity, because these files include so many important information that helps competitors to copy the product very easily if these files are available to them. So that's why these files are very important. In this stage, what we are going to do is we are going to generate three important steps or three important files. One is Gerber file. Yes, you heard it correct. Gerber file. Gerber files are the important files for PCB fabrication. They are the information for the fabricator to manufacture the PCBs or the bare PCBs that we want to develop our product in a large scale. Then we have a second important data or maybe information that we are generating, that is all about bill of material and pick and place information. Bill of material, as I already said, they are very important to procure the component and even help in PCB assembly activity. Wherein pick and place information is a kind of coordinate information for the machineries which will pick the component from the container and place it on the PCB while we are going for an automated soldering activity. If we are going for a mass production, then this pick and place machine information is going to play a vital role. Otherwise, it is not going to do it any small scale manufacturing. So pick and place information and bill of materials are very helpful for PCB assembly activity. Thereafter, the third important step or third important file that we are going to generate is all about firmware and its testing protocol. So we call it as a testing firmware. This firmware which is going into the hardware which will make that hardware into a live. Say for example, if we are developing a hardware and if we are putting a software inside that, then it becomes a complete product. Otherwise, it doesn't make any sense, right? Because the hardware without a software is a dead material, and without a hardware, a software is no materialized. So that's why we need to make sure that we will be developing a final firmware which is a final release of that particular product, so that that particular software is kept inside or maybe uploaded inside that particular hardware, so that it can function as per the requirement designed, developed and manufactured in the last 8 different steps that we discussed so far. So these are the 9 important steps involved in new product development for any electronic product or a design in our ESDM industry. I hope you have enjoyed the entire journey of 9 different steps involved in new product development for ESDM industry product. I believe that you have carried some information and knowledge in this particular tutorial. Please consider subscribing to our channel linked frequency for such more informative content. Tune yourself to make a difference.